Hi guys. All right, today in math we talked about adding whole numbers, and our goals today were to learn how to add the numbers fluently and to learn how to justify the reasonableness of our answer. So we did some review with rounding, and so we practiced that, and then we practice. When we do that, we estimate our sum. So again, we're adding today. We're practicing standard algorithm, and then we estimated. Our reason for doing that is to make sure that our answer makes sense. So we just some review of different rounding with the tens, hundreds, and thousands, and then just some review of basic addition. I don't know why this slide isn't coming up. There it is. Okay, so some of the vocabulary that we'll be using: regrouping, talking about place value, the sum, reasonableness, estimation, and standard algorithm. These slides aren't wanting to stay up. Let me see. Let me try it that way. There it is. Okay, so let me get my pen. All right, so here, let's just review some rounding. So here, this is talking about taking the number 245 and rounding it to the nearest tens place. So if you notice in 245, the digit that is in the tens place is the 4. And so if you notice here, that 4 stands for 4 tens. This is the hundreds place, the tens place, and the ones place. So because that 4 is in the in the tens place, we're talking about 4 tens. So that would be 10, 20, 30, 40. So it has a value of 40. So you notice we see that here on our number line. And then because we're going to the nearest 10, 245, we need to find the tens that 245 is between. So the next 10 after 40 would be 250. Then we have to see how many of these, like we're going down the number line here. We have to be able to see how they're counting. So let me erase this. So if we start counting, I'm just going to check it by 1. So 240, 241, 242, 43, 44, 45, 46, 47, 48, 49, 50. All right, so they're counting by ones. So 245, if I'm counting as I jump, this would be 241, 242, 243, 244, 245. So 245 is right there. And so in order to find what the nearest tens are, we're going to see what it's closest to. Well, in this case, I've got 5 jumps. So there's 1, 2, 3, 4, 5 that I did. But then on the other side, to get to the other 10, I've also got 1, 2, 3, 4, 5 jumps. So 5 jumps on one side and 5 jumps on the other. Since that's the same, we always round up to the next 10. So this 245 is nearest 250. Then on the next one, so anytime you see that 5, we're going to go and round up. All right, on this next one, we've got 4,567. We're going to, again, the nearest 10. So I'm going to look. I've got 4,560 and the tens place. So this is my thousands place, my hundreds place, my tens place, and my ones. And the thing that's in the tens, because we're doing 10, nearest 10 is the 6. So that's why I've got the 60 here. And then if I go to the next 10, that would be 4,570. So now I need to find, again, this looks like we're jumping. Every time we jump, we're going up by 1 again, and I can check it, and that's true. So to find where that is, I'm going to go 7 more. So that's 60, 61, 62, 63, 64, 65, 66, 67. So 4,570. 567 is right there. And if I notice, so I did 1, 2, 3, 4, 5, 6, 7 jumps on the left side, and I only had to do 1, 2, 3 jumps on the right side. So if we're looking for nearest 10, it's closest to 4,570 because it's less jumps to get there. So that would be our answer. So it's nearest 4,570. All right, on the next one, let me clear this so we can clean this up a bit. All right, the next one we've got 749, and we're rounding to the nearest hundred this time. So I've got my hundreds place, my tens place, my ones place. Here's my hundreds. So I've got 700 because this 7 in the 100 stands for 700. So 700 and the next 100 would be 800 if I'm counting by hundreds. And this time, I know just by looking at this, if I start counting 701, 2, 3, 4, I'm not going to get to 800. So that can't be how we're counting by. So this time I'm going to try something different, and I'm going to count by 10. So 7, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So another 100 will be 800. So that makes sense. So this time we're counting by tens. So I need to be able to figure out which these number lines look the same, but then when you start looking closer, you notice that that one is each one stands for something different. So it's always good to check it. All right, so here I've got 749. So 749, if it's counting by tens, it's not going to land on one of these lines. So I've got to get to 750. So that would be 1, 2, 3, 4, 5 right here. And if I stop there and put my 750 there, 749 is just going to be right next to that line. Not quite there, but just almost. So then if we look, the distance from here to here is going to be shorter because this right here is my midway point. So it's going to be more distance over here. So I'm getting the nearest. So this one is going to round to 700 because it's closer than it is to 800. All right, so just a little bit of review from third grade and fourth grade of rounding on that. And then let's go to the next slide. In class, we had grid paper, and the grid paper we used to help us with using our find where my pen went. There it is. So when we were writing, we would put the numbers, like if I did 150 plus 122, we would use the grid paper to help line up our digits. That way every number stayed where it needs to be, and all the place values, so here's my hundreds, my tens, my ones, all the placed values were kept in that same column. So this can help kind of space out numbers and keep everything neat and organized. All right, the next, let me get rid of this. Next, we did a couple practice problems. So I'm just going to do one here. So let me clean that up. All right, so it says the population of Clay County is 18,413, and Mickelson County's population is 19,768. Our question is, what is the total population of these two different places. So we've got the standard algorithm over here in one column and the reasonableness in another. And our job today was, if we go back to our goals, was number one, adding and doing that correctly and making sure that we're adding correctly with the standard algorithm, but also that we're going and we're checking the reasonableness to make sure our answer makes sense. So we're going to check that first. So if I'm going to write them over here, 18,413 and 19,768. These are my two numbers. And if I'm trying to find the total, that means I've got I've got one of my, I've got one population and I've got another population. I'm trying to bring them together and find the total. That means I need to add them. So I'm just going to come over here and I'm going to round these. I'm just going to go to the nearest hundred. So here's my hundreds place right here. I've got the 8 and the 9. And you can use the number line, or you can also just look the digit to the right. So to the right, I've got a 4, and so you find the number in its spot. So that's I'm sorry, not hundreds, thousands place. Let me go back and correct myself. That's the thousands place. So if we round to the nearest thousand, we're going to look into the hundreds place and we're going to ask ourselves, is this 5 or more? And we say 5 or more, raise the score, or 4 or less, let it rest. So in this case, this 4 right here is less. So everything to the left is going to stay the same. The 8 is going to stay the same because we're letting it rest. We're leaving it alone. And everything to the right runs to 0 in a fright. Over here, find the number in its spot. We've got the 9 is in our thousands place. We're going to go next door, see what we've got. We've got a 7. 5 or more, raise the score. So in this case, we're going to raise it, and it's going to bump that 9 up to a 10. So we're going to have to do 20. We're going to regroup, and everything to the right is going to run to 0 in a fright. So these over here on the left are your actual numbers, exact populations. But I could say for Clay County, they have about 18,000 people. And then in Mickinson County, they've got about 20,000 in their population. So if I want to find the total, I'm just going to add those up. So 0, 0, 0, comma, 8, and 3. So their total population is about 38,000. Now I can come over here and my answer, like they're not going to match because I've changed them, but they should be close. They should, I shouldn't get something that's completely, hundreds of thousands more. If so, or less. If so, I know I did something wrong. So we're going to add our ones column, then we're going to go to the tens, and we're going to start on the right and go all the way down to the left. So 8, 9, 10, 11. 6, 7, 8, 7, 8, 9, 10, 11. 9 and 1 is 10, plus 8 more is 18, and 3. So 38,181 is my actual answer. And when I checked for reasonableness, I got 38,000, which is very, very close. So this checks out. I'm happy with that. And so I know that I can go back over and check it again. But I know that my answer is reasonable and makes sense. So I'm good with that. All right, let me clear this. Whoop. Where is that other one? Oh, there. That's easier. All right. Now we did a couple other problems, and then we had this exit ticket. A lot of students did very well on the first and the last. We got a little bit stuck on this middle one, some of us, just because it's going all the way into the millions. And so when you've got a lot of digits like this, one thing that I consistently saw was just neatness. And so, really, just using those grids helps to keep everything neat and in their own columns. We've got lots of numbers, lots of regrouping going on. So, it just kind of keeps you organized and making sure that you're not forgetting any numbers. Or another thing I saw was with the regrouping that we would add correctly, but we would forget to put the digit. If it was 11, we would forget to put the one that's in the tens place in the next column. So neatness and just making sure you're writing down the right number. And most people were successful with this, so that was good. But that's just a review of our rounding to check reasonableness, and then also using standard algorithm with addition with whole numbers. So thanks for watching.